Today we are going to solve some chapter review questions about moments from our new M1 book. So please turn to page 141. I am going to start with question 1, then hopefully solve question 2, 4, 8, and finish with question 9. So, please turn to page 141. I am going to start with question 1. Here we have a plank length 6 meters, weight 100 newtons, rest in a horizontal position on supports B and D, where AB is 1, DE is 1.5. If we have supports, that means we have normal reaction forces on supports. So we have RB there and RD there. Remember, we have to know the distances of the reaction forces from A. And this is point A. The distance of B is from A is 1 meter, and the distance from D to E is given as 1.5. The total is 6. Because this is 1.5, that length there is going to be 6 minus 1.5 meters, so it is 4.5 meters. The distance from A to D is 4.5. I need all the distances of every point on the plank with respect to A. Why? Because I am going to take moment about A. So if this is 1.5, if the distance from D to E is 1.5 meters, the distance from A to D is 4.5 meters, because the total distance is 6 meters. And a child of weight 145 newtons stands at C, at the midpoint of AE. So we have a force of a weight of 145 newtons at the midpoint. So because it is at the midpoint from A to C to the child is 3 meters. Midpoint of 6 meters is 3 meters. The child is molded as a particle and the plank as a uniform rod. So if it's uniform, we have another force here. The weight of the rod, which is 100 newtons. So if the child is at the midpoint, and the center of the mass is also at the midpoint because the plank is uniform, so they act at the same point. The child and the plank are in equilibrium. The magnitude of the force accepted by the support on the plank at B is part A, part B is RD, and we are going to carry on. So we have 2 rules to apply. What are those rules? Rule number 1, net force must be 0. So we have 2 upside forces, 2 forces pointing upwards and 2 points pointing downwards. So RB plus RD is equal to 145 plus 100. So RB plus RD is equal to 245 newtons. Now let's apply the second rule. Moment about A. That symbolism here means moment about A. And anti-clockwise moments must be equal to clockwise moments. And from A, because RB and RD point upwards, clockwise turning effect on the rod, because I choose A as the pivot and forces to turn in the anti-clockwise direction. What is the distance of RB from A? 1 meter times the force RB. What is the distance of D from A? It is 4.5 times RD. Remember, moment has a simple formula. It is force times the perpendicular distance, or distance times the perpendicular force. We are taking moments about A, and the distance of RB is 1 meter from A, so it is 1 times RB, and the distance of D is 4.5 meters from A, so it is 4.5 times RD. And they have an anti-clockwise turning effect of the plank if the pivot is A. Now we have two forces here pointing downwards, which cause a clockwise moment on the plank if the pivot is A. So it is going to be, we have the same distance for two forces from A, 3 times 145 plus, again, the center of mass is at the midpoint, so it is again 3 meters from A, 3 times 100. So RB plus 4.5 RD is equal to 435 plus 300. So RB plus 4.5 RD is equal to 735 newtons. Now we have two equations here in terms of RB and RD. There we have the first one, RB plus RD is equal to 245. There RB plus 4.5 RD is equal to 735. Let's use simultaneous equations to find the values for RB and RD. Put a negative sign there and subtract them. 3.5 RD is equal to 490. So RD is equal to 490 divided by 3.5. So it is 140 newtons. And this is the answer for part A. No, we have to find RB first. Sorry, part A was to find RB. So we have to find RB first. So I'm going to multiply that one by 4.5 to keep things in order. Minus 3.5 RB is equal to, let's use a calculator. Minus 367.5, so RB is going to be 105 newtons, RB plus RD. This is the answer for part A. RB plus RD is 245 newtons. RB is 105. So RD is equal to 105 plus RD is equal to 245. RD is equal to 140 newtons. These are the answers for part A and also part B. Let's carry on with the question. Remember, these are the questions from chapter review. Of the new book for M1, chapter 8, and this is question 1. It is on page 141. Let's carry on with the question. These are the answers for part A and part B. Sorry. The child now stands at a different point F on the plan. The plan is in equilibrium and on the point of tilting about D. Very, very important. Point of tilting about D means RB, be careful, RB, that one is 0. The other one is going to be 0. That's the meaning of tilting about. If all the forces is on D, that means there is no reaction force on B. So we have to redraw the graph again for the question. This is point A. This is point E. No RB there because it is going to be tilting about D, means no RB there. Still, we have center of mass pointing downwards 100 newtons. Remember, child has changed its position, comes somewhere here, but you don't need to know its place. But to be tilted about, for the plan to be tilted about D, it must come, the child must be somewhere here. But the point is F, but we don't know its real place. And we don't care about its place. We are going to find the length of the child from point A. This is unknown. Carry on with the question. The question asks to find the distance df. First of all, let's find the distance of the child from A to F, and it is very easy to calculate df then. So I am going to call this distance of the child from point A is x. I called it x. And what is the distance from A to midpoint? It is 3 meters, didn't change. What is the distance from A to point D? It is 4.5, already calculated. So have a new situation here because RB is not anymore in our system. So we have to apply our two rules for equilibrium. F net must be 0. So we have one force pointing upwards and we have two forces pointing downwards, center of mass and weight of the child. So RD is equal to 245 newtons. So the second thing is anti-clockwise moments must be equal to clockwise moments. We have one anti-clockwise moment here due to a single force which has a direction upwards, and its distance, it is RD, and its distance from A is 4.5 45. Do we know RD? Yes. Again, with the help of the calculator. 1102.5 is equal to 300 plus 145x. And x is 5.53 meters. But this distance is from A. From A, the distance is 5.53. And the distance from A to D is 4.5. So DF is going to be, this is the distance from A to D. So from D to F, distance is going to be 5.53 minus 4.5. So it is going to be 1.03 meters. Yes. Do you have any questions? I am going to check Messenger and WhatsApp for your questions. If you have questions, ask. And I am going to send the picture of the board to you. This was the answer to question 1 on the chapter review. So, if no questions, I will solve question 2 for you. Now, it's time to solve question 2 from the chapter review questions of chapter 8 moments, which is, I think, on page 142. So, turn your pages to 142 to be able to solve question 2. Here is question 2 from chapter review of chapter 8. Let's clean the board. Page 142, chapter 8, M1 book. Question 2. Let's read the question. A uniform rod AB has length 4 meters and weight 150 newtons. Draw the graph. We have two supports here, C, so we are going to have RC there and D there. So we have a normal reaction force at point D as well. This is point C, this is point D. And the total length of AB is 4 meters. AC is 1 meter. This is 1 meter. And AD is 2.5 meters. From A to D, it is 2.5. Remember, we have to know the lengths corresponding to point A, because we are going to take moments about A. That's a very important point for us. AE, let's carry on. A particle of weight W is attached to the rod at point E, where AE is X meters. So it can be anywhere. Say that it is there. Point E is there. We don't know the point. We don't know the place of point E, where that extra particle is attached. But we know its distance. It is X meters from point A. AE is X meters. And its weight is W. The rod, and it is a uniform rod, so we know that the weight here of the rod is 150 and it is at the midpoint. So it is 2 meters from point A, because this is uniform rod, uniform plank, uniform beam, means the center of mass is at the midpoint. So if AB is 4 meters, the midpoint is going to be 2 meters from point A. So we know all the distances and we know all the weights, and we have the rod remains in equilibrium, and the magnitude of the reaction at C is, that reaction C is now equal to the magnitude of the reaction at D. Let's call them R, because they both are equal to each other, so I call them R. Why I call them R? Because they are equal in magnitude. So let's apply our rules. F net must be 0. So we have two forces pointing up, R and R. RC is R, and reaction at D is also R. And we have two forces pointing downwards. They are W and 150. So 2R is equal to W plus 150. So R is equal to W plus 150 over 2. Now, we have to apply our second rule. And second rule always says anti-clockwise moments must be equal to clockwise moments. And we are going to take our moments about point A. Always use point A unless stated. So, if this is point A, our pivot, RC is pushing up, tries to turn the beam, the rod AB, in the anti-clockwise direction. And what is moment? It is force times the distance. What is the distance here? 1. What is the force? R. And we have D there, we have RD there, and its magnitude is also r, and the distance from A to D is 2.5. So again, in the anti-clockwise direction, and has a distance 2.5 meters from point A, and its magnitude is r, must be equal to the clockwise moments. And we have two forces which tries to turn the beam in clockwise direction. We have the weight of the rod, weight of the beam, which is 150 newtons, and 2 meters from A. So 2 times 150. And we have the particle here at point A at an unknown distance. The distance is unknown, so I select a point E and put the particle there, which has a weight W, and a distance x, which is given in the question from point A. So x times W. Now we have r plus 2.5 r, which is equal to 300. 2 times 150 is 300 plus x W. So we have 3.5 r there, which is equal to 300 plus x W. We know r in terms of W, so let's rewrite there 3.5 times W plus 150 over 2 is equal to 300 plus xw. So that means 3.5 over 2w plus 3.5 times 150 over 2 is equal to 300 plus xw. And yes, we need to show everything in terms of, we need to show w in terms of x. So (3.5 over 2w minus) I took that one to the left hand side. Xw is equal to 300 minus 3.5 times 150 over 2. W in the brackets is 3.5 over 2 minus x is equal to 37.5. When we check the question, we have 4x. So I am going to multiply the whole equation by 4. Why 4? Because when we check the question, we see that coefficient of x is 4. So I have to put 4 there. So to be able to put 4 there, I have to multiply everything by 4. So W 3.5 over 2 times 4 is 7. 4 times x is minus 4x. And 37.5 times 4 is 150. So W is equal to 150 over 7 minus 4x. This is part A. Now deduce the range of possible values of x. Now we have to talk about x. Where x can be. So we know that AB for part B, AB is equal to 4 meters. So x must be less than 4. And 7 minus 4x, that part must be greater than 0, because we cannot have a weight less than 0. So we have two conditions here. Either x is going to be less than 4, say that less than or equal to 4, because AB is 4, we cannot have a weight there. The particle at E must be on the rod, on the plank. So, and for the division rule, if we have a weight is always positive. So 7 minus 4x must be positive and not 0. And that means seven is greater than 4x, x is less than 7 over 4. And these are the two restriction values for x. Yes, these are the answers for, this is the answer for question 2 on the chapter review questions. Please check. So let's have a proper answer for this one. X is less than 7 over 4, because it's a length, it must be greater than 0, of course. This is how we write the answer for x. Maybe at point A, so yes, it can be 0 as well. It can be on point L or A as well, so x can be 0. Any questions? If you don't have any questions, I'm going to solve question 4. Checking my phone for your questions. No questions? And let's give the picture of the board. So I see there is no question, so I am going to solve question 4, which is at page 142 as well. Yes. So I'm going to erase the board and solve question 4. This is a revision for moments in M1. And I'm going to solve question 4 on chapter review on page 142. Question 4. Let's read the question. A non-uniform rod, we have to be very, we have a very important condition here. Center of mass is not at the midpoint. It can be somewhere else, but not at the midpoint. So we have a rod, non-uniform rod here, AB, again AB. We have two pivots there, so that means we have two normal reaction forces at point C and D. From A to C is 1.5 meter, 1 meters. And from R to D, from D to B, it is 0.5 meters. And the length was 4 meters from A to B. So from A to D, we have to know all the distances with respect to A, because we are taking moments about A. Will be 4 minus 0.5, 3.5 meters. Be careful while calculating the distance from A. Given the distance dB does not mean anything to us, because we are going to take moments about A. We need to know the distance of the force from A, and that is very easy to calculate. The total length is 4. From B to D is 0. Stay somewhere here. It is 150, and the distance is x from A. And we have a particle weight W newtons is placed on the rod at A. We have here a particle with weight W. This is 150 newtons. The rod remains in equilibrium, and the magnitude of the reaction of C on the rod is 100. This is given as 100 newtons. Do we know anything about RD? No. So show that 550 plus 7W is equal to 300x. So let's apply our rules here. F net must be 0. So upward forces must be equal to downward forces. We have two upward forces here, 100 newtons plus RD. And we have two downward forces, 150 plus W. These are the two forces acting downwards, two forces acting upwards, and two forces acting downwards. So RD is equal to, taking that 100 there as negative, 150 minus 100 is 50, 50 plus W. So RD is 50 plus W, and leave it there and apply the second rule, which says anti-clockwise moments must be equal to clockwise moments. So second rule says anti-clockwise is equal to clockwise, and we have to take the moments about A. That's my rule, not the rule of moment, not the rule of physics, but that's my rule. Always take the moments from the leftmost point. So we have two forces pointing upwards, which gives an anti-clockwise moment, and the distance is 1 times 100. The distance of C from A is 1, and the force is 100. The distance from A to D is 3.5, and the force is RD. It's an unknown. And when we come here, we have two forces pointing downwards, trying to have a clockwise moment on A, on the rod AB, but the distance of A to W is 0 because it is on A. If a point is on that point, the distance from A to W is 0. 0 times W. The distance is 0 because W is already on point A. Plus, what is the distance from A to the center of mass? It is X. It is not at the midpoint because this is not a uniform rod. It is a non-uniform rod, and the distance from A to the center of mass is given in the question as X times 150. So 100 plus 3.5 RD is equal to 0 times W is 0, 150 X. And we want an equation in terms of W and X. So in place of RD, I am going to substitute that 100 plus 3.5, 50 plus W is equal to 150X. 100 plus 175 plus 3.5 W is equal to 150X. This is 275 plus 3.5 W is equal to 150X. We want to have 7 there. When we check the answer, we have 7 W there. So multiply the whole equation by 2. 550 plus 7 W is equal to 300X, and therefore shown. This is the thing, this is the equation that we have to show. Now the question is going to change. This is the answer for part A. Now the question is going to change. The particle is now removed from A. I am going to take this A. This particle with a weight W is going to be somewhere else, not on point A. And place on the rod B. We are going to put that W on B. It is not on A anymore. In part B, it is on B. Still, we have 150 newtons there, which is at X distance from A. It is the center of mass. And do we still keep the pivots? Let's check. The rod remains in equilibrium, and the reaction of C on the rod now has magnitude 52 newtons. This is RC 52, and we have RD there, still unknown. This is the case. This is the case in part B. Obtain another equation connecting W and X. Let's use part B to have another equation. Now, rule 1, F net, sum of F net must be 0. We have two forces pointing up, 52 plus RD. And we have two forces pointing downwards, 150 plus W, or yes, so minus is equal to 0. So RD minus 98 minus W is equal to 0. RD is equal to 98 plus W. And apply the second rule of moments. Anti-clockwise moments must be equal to clockwise ones. Moments about point A. What is the distance from A to C? Distance from A to C is 1 meter. This is 1 meter. 1 times 52. What is the distance from A to RD, which causes an anti-clockwise moment. And the distance from A to D is 3.5 meters, as in that, as you can see in this diagram there. RD. We have two forces which tries to cause a clockwise moment there, and from A to the center of mass, which has a weight there, which is the weight of the beam, which is the weight of the rod AB, is X, and force is the weight 150, and this we have an object, we have a particle there, weight W, and it is on B, and the distance from A to B is what? 4, because total length is 4 meters, times the force, which is the weight. So 52 plus 3.5 RD 98, and in place of RD I am going to substitute that one because I need an equation in terms of W and X only. So 343 plus 3.5 W is equal to 150X plus 4W. So $395 plus 3.5 W is equal to 150X plus 4W. 395 minus 150X is equal to 4W minus 3.5W. 395 minus 150X is equal to 0.5W. Multiply by 2 to have a proper equation here. 790 minus 300X is equal to W, and that's the second equation. Now part C, calculate value of X and value of W. We have two equations here, and the first one is 550 plus 7W is equal to 300X. And we have the second one there, so I am going to substitute 790 minus 300X in place of W. Minus 2100X plus 300 is equal to 300X. So let's add these two numbers there. 680 is equal to 2400X. So X is 2.53. So W is going to be 31 newtons. That's the answer for question 4. Now let's send picture of the board. Yes, if you don't have any questions, I will solve question 8 now, which is on page 143. If you don't have any questions, I am going to solve question 8, which is on page 143. Here, as we have a correction, because this is recurring, W is going to be 30. Thank you, Ekin. Thank you very much. I corrected. Thank you. Thank you very much. Yes, if you don't have any questions, I'm going to solve question 8 on the same chapter review. Yes. Question 8. Page 143, question 8 on the chapter review questions. Now, a plank AB has 50 kilograms and length 4 meters. Again, the length is 4 and the name is again AB. We have one tension here, call it tension A. We have another tension here called tension C. These are not reactions, but these are tensions. A load of mass with 25 kilograms is attached to the plank at B. We have 25G there as the weight. The loaded plank is held in equilibrium with AB horizontal by 2 vertical ropes attached A and C as shown in the diagram. The plank is modeled as uniform rod, which means the center of mass is at the midpoint. So this is 2 meters because the total distance was 4 meters. And this is point C. Given that the tension in the rope at C, that one is 4 times the tension in the rope at A. This is T, this is 4T. And calculate the distance CB. Again, rules applied. F net is equal to 0. Upward forces must be equal to downward forces. So, T plus 4T is equal to 50G plus 25G. 5T is equal to 75G. T is equal to 15G. So this is 60G, 4 times 15G, and this is 15G. And apply the second rule, anti-clockwise moments must be equal to clockwise moments. So moments about point A, we have 2 upward forces trying to turn the rod AB in anti-clockwise direction, but the distance of TA from A is 0, 0 times 15G. We have another one there, which is, and call the distance from A to C X because it is unknown. So from A to C it is X, and the force is 60G, and the clockwise moments are 50G, which is 2 times 50G, because from A to the midpoint is 2 meters, because the total distance from A to B is 4 meters. So plus this is also the 25G tries to turn the rod AB in clockwise direction. So A to B, the total distance is 4, and the total force weight there is 25G. 0 times anything is 0, so 60Gx is equal to 100G plus 100G. G is cancelled. X is equal to 200. 60x is equal to 200. X is equal to 200 over 60. X is equal to 10 over 3 meters. So, from A to C, it is 10 over 3 meters. What is the distance from C to B? So, the total distance is 4 meters. So, from C to B, it is going to be 4 minus 10 over 3, which is 2 over 3 meters. Any questions? Let's have the answers as pictures. And if you don't have questions, I am going to solve question 9, and that will be the last question for today. For moments, for revising moments. Remember, this is a revision for moments. Page 144, question 9. Let's turn the page, see the question, read the question, and carry on. Yes. A beam AB has weight 200 newtons and length 5 meters. Again, its name is AB. And we have a pivot here, so we have to have an R. And we have C there, we have to have another pivot there, so we have to have another normal reaction force at point C. The beam rests in equilibrium in two horizontal positions on two smooth supports. One support is at A and the other support is at B, where BC is 1. If BC is 1, from A to C it is 5.14 meters, because the total distance was 5, CB is 1, so A to C has to be 4. And remember, RA, resistance, normal reaction force of pivot is also on point A. And the beam is modeled as uniform, which means the weight is at the midpoint, the total distance is 5. So from A to the midpoint it is 2.5 meters. And the weight is 200 newtons, and the distance from A to the midpoint has to be 2.5 meters. Find the reaction on the beam at C. Yes, apply the rules. RA plus RC upward must be equal to downward forces. And we have one downward force, which is the weight of the rod of the beam, 200. And let's apply anti-clockwise moments must be equal to clockwise moments. We have 2, and the moments are going to be about point A. The distance from A to RA is 0. The distance from A to C is 4 and RC, and we have one force pointing downwards, and that 200 Newton weight of the beam tries to turn the beam AB in clockwise direction, and its distance from A is 2.5 and its force is 200. So 4RC is equal to 500. RC is equal to 125 newtons. This is the answer for A. Now, a woman of weight, now the condition for the question is going to change. We are going to have a woman on the beam. A woman of weight 500 newtons stands on the beam at point D. Do we know the point D? No. The beam remains in equilibrium. The reactions of the beam at A and C are now equal. Let's have another diagram for part B. This is RA, which is equal to R. Also, RC is also equal to R, because the reactions on both at A and C are equal. And we have a woman of weight 500 newtons at an unknown distance from point A. So call the distance X. We don't know the distance of the woman from point A, but we know the weight of the beam. It is 200 newtons and it is 2.5 meters from point A, because it is at the midpoint, and AB, the total length of the beam is 5 meters. So and remember, from A to C, the distance is 4 meters because the total distance is 5, and from C to B it is 1. So from A to C it is 4, already calculated there. Now apply the rules. F net must be 0. Upward forces are R and R. Downward forces are minus 200 and 500. So 2R is equal to 700. R is equal to 350 newtons. Both are reaction at A and reaction at C. They are equal to each other and they are both 350 newtons. Second step is the moments. Anti-clockwise moments must be equal to clockwise moments, and this one tries to turn the beam in anti-clockwise, that one also in anti-clockwise, but the distance of reaction at A is 0 from A. 0 times 350 plus the distance from A to C is 4. 4 times 350 is equal to, these are the two forces which tries to turn the beam AB in clockwise direction. The distance of the weight of the beam from A is 2.5 and the force is 200. 2.5 times 200 plus the distance of that woman with a weight 500 from A is unknown. We called it X, and the force is 500. So this is 0, 100 and 1400 is equal to 500 plus 500x. 900 is equal to 500x. X is equal to 9 over 5, which is 1.8 meters. X is 1 meters away from the woman, is 1.8 meters from point A. So this is the last example for moments. If you have any questions, just ask. I am going to send the picture of the board to you by WhatsApp or Messenger. If you have any questions, do not hesitate, just ask. I know I have to clean the board. Yes, if you don't have any questions, and I couldn't find any questions on my Messenger or in my WhatsApp, that will be the end of the lesson. For those who have integration of P4 in the afternoon, see you then. For those who is only taking M1, see you on Monday. Have a nice weekend. Bye. End of the video. Çok güzel.